Hello everyone. In the previous video we overloaded the equals operator and the plus operator. Something to notice about these operators is that the input is a 2D shape and the output is a 2D shape. Right? We are only defining the behavior of shape 2D with itself in operators. So in this video we're going to overload the multiplication operator, but in two ways. One with a relationship with a shape and the other one with a value. So why don't we go about declaring those in this header file, and we will implement them in the C++ file. So like the other operators, this is going to return a shape 2D, the class itself. And when we overload this multiplication operator specifically, what we're going to do is we're going to have it as the same input and output. Right, this doesn't seem too far different from the other methodology that I've used for overloading the plus operator. However, here it's going to get a bit different. So we're going to return the shape 2D class, and we're also overloading the operator. But now what we're going to do is that we're going to define another type of input. Right, so again, to review, overloading operators is adding additional functionality to operators that are already there. So here, this is quite interesting, and let's kind of play it out in comments. So here what I'm able to do is I'm able to do something like shape 2D x and maybe give it a value of 5 and 5. You know, what I'm able to do here now is I can do something like, I have two options. We'll have two shapes, shape 2Ds. I will have y, and I will have shape 2D z. Okay, and in here what I can do is something pretty neat. I can actually do something like this. I can say this is going to be equal to x times x, so it's going to multiply itself. Right, well, we're essentially going to have x squared, which should be a 25 by a 25 shape 2D. And the alternative way of writing this is actually saying something like this as well. We can actually take advantage of the overloaded equals operator. Right, but for this case, I will use a constructor this way. And for z, we also have the option of doing something like x times 2. Right, so here in this example, we're using this version of the multiplication operator. In this example, we're going to be using the second version of the multiplication operator. Right, and this is something that makes sense. Well, that should make sense. Here we want to multiply x with x, and this means we want to multiply the length by the length and the width by the width and return that result. So this should be equivalent to creating a 25 by 25 shape 2D class. Here, what we're thinking is that this would be 5 times 2 on the length and 5 times 2 on the width. So this should be a 10 by 10 shape 2D. And this is kind of the reasoning behind it. We can continue overloading operators. If I had a rectangle class, I might want to do that. The idea here is that you as the programmer get to define the behavior. So let's go about implementing these operators. So we need to follow what we've been doing before. We know that both operators are going to return a shape 2D class, and they are methods that belong to the shape 2D class. So we're going to overload the operators, and I'm going to have something like this. I got to repeat the inputs that have been defined in the header file. And this is actually going to be very, very similar to the plus operator. So I'm just going to copy that, and I'm going to paste that here. But instead of adding like we have here, we are going to multiply. And again, I use the set length method just to safeguard what's going on with my inputs and to make sure there's no errors. Like, the thing that comes to mind is that I don't want to be able to have a negative length for my 2D shape or a negative width. We're also using the getters, so that way we don't have to directly access the private data without a safeguard, without, keeping these values the same, because these have a const expression with it when we return the private data. So whatever we're returning is constant. So there's no chance that we're going to modify the attributes that belong to the class itself and any other class. Right, and this is just for the sake of data preservation. So overloading this operator is quite simple. If you'd like to overload the subtraction operator, would be very similar and relatively simple as these are. Overloading the division operator, however, would be a little bit interesting, and we'd have to account for some things. In theory, it shouldn't be too difficult because of our set length and set width. They won't allow the attributes to be 0, so there shouldn't be a problem, but we never know. So it would probably be important to put some safeguards in it. Anyways, moving on to the next overloading operator. Again, it's going to have the same behavior as the previous operators. We want to return the shape2D and that this operator belongs to the shape2D class. The only thing that's different is that this has a different input. While this does have a different input, the methodology that which we are going to implement this is not going to change. I can actually copy this yet again, but instead of multiplying by shapeGetLength, we are just going to multiply by x. And again, this is all wrapped within setWidth and setLength, so that way if I try to be sneaky and try to multiply by 0, well, that's okay, because setLength and setWidth will fix that for me and set the values equal to 1, right? And this is one of the practicalities, right? Because I don't think you immediately thought about multiplying this by 0. However, if this happens, you guys are okay. The program will be okay, because setLength and setWidth, which are doing their proper jobs as setters, they're taking care of any sort of errors in modifying the attributes, and that's their job. And this is why it's best practices to use these kind of things. In the previous video, I ended with finding a way to print out the class like that, and unfortunately this is how we are also going to end this video. But don't worry, in the next video we'll talk about overloading the double angle brackets operator, why it's so special, and the concept of using a friend function. Thank you.